Okay, so today we are going to see permutations. So basically, I'll take the easiest case. So basically, if you have five numbers, let's say 1, 2, 3, 4, 5, you want to count all the possible ways in which they can be arranged. So arranged means, let's say you have these five places and you want to arrange them. You put one here, you put three here, four here, two here, five here. Now this is one permutation. The other way you can arrange them is you can maybe shuffle them more. You can put two and then four, five, one, three. This is another permutation. So basically what we are going to see today is when you count all the permutations, all the different permutations that are possible from these five numbers, basically shuffling them. When you count them, the answer is count of five things when shuffled is 5 into 4 into 3 into 2. So when you take six numbers and you shuffle them, the answer is 6 into 5 into 4 into 3 into 2. So basically if you take n numbers and if you shuffle them, the answer will be yes, n into n minus 1 till 1. So this is so they have a shorter notation to write this. Like every time to write this is very long, right? So they've given a short notation called exclamatory mark. So whenever you see n exclamation, you say when you say it, you don't say it in exclamation, you say it n factorial. It's called factorial. So whenever you see this is actually equivalent to this. They have just not written it this way because it's longer. Okay, so we are going to see why this is the case. Why when we count all of these, it will always be this. Okay, so I'm going to be give two ways in which to see how this formula works. So if you let's say let's take an example scenario. Let's say you have three friends, Ram, Vijay and Ajit. Okay, now they have booked cinema tickets in a theater. So these are the seats. Now we want to know how many different ways your three friends will sit. So maybe Ajit will take the corner seat, Ram and then Vijay, or it will be RV, or it will be VAR, right? So you want to count all of these. And let's say you have another problem where Ram, Vijay, Ajit, and a fourth friend of yours, let's say Arvind. Okay, let's take Sujay so that we get a different letter. Okay, so and let's say this time they have booked four seats. And you want to know all the different ways in which they can sit. So it can be Ram, Vijay, Ajit, and then Sujay, or anything. SAVR, anything. So let's say you have these two problems. Now, let's say you solve this problem. You have two problems, right? Let's say you solve it. You know the answer of this problem. You know that okay, we know that when you shuffle three things, it is 3 into 2 into 1. Let's say you know this somehow. So you know that there are 6 ways in which they can be seated. Now, to find the solution of the second problem, we are going to let's just follow along with me. You take this AVR. Okay, let's just take one permutation out of the first answer. Now Sujay, now the problem in 2 is where will Sujay sit, right? When you take the first instance of the first problem. Now Sujay can sit here, or he can sit in the middle, here, or here, or here. These are the four possible ways in which Sujay can sit in AVR. If you take ARV, again Sujay will have four different places, four choices to sit. Because the difference between the first problem and the second problem is there's a fourth seat and a fourth person. Now this fourth seat with the person can be anywhere here, right? It can be here in the corner or here, it can be put in the middle. So, but there are just only four possible options for you. So you can take every permutation, totally you have 6 of them, and you can make Sujay sit in all the 4 different places, and you can create 4 different permutations out of them. 4 different permutations that will come here, that you would want to count here, right? So this will become 4, this will become 4, and so like that, by making Sujay sit in all 4 different places, you can create this set from this set. So if you want to shuffle 4 things, let's give a notation. Let's say P4 is equivalent to a count of all the possibilities in which 4 things can be arranged. Okay, so P4 is this problem, P3 is this problem, because we want to shuffle 3 things here. So P4, and according to us P3 we magically found out 6. Now so when you see each of these items will give out 4 new permutations of this type. So 4 into 6, 24 is P4 if you know P3. So basically P4 is 4 into P3. And similarly P3, if you follow the logic properly, you can give the same logic for P3 and say that P3 is equal to 3 into P2, and you can say P2 is equal to 2 into P1. And how many different ways can you arrange one person? Only one way, so that's just 1. So basically P4 will then become 4 into 3 into 2 into 1. So this is one way of seeing how this formula works.